The objective of this lesson is to be able to use concrete models and pictures to solve equations with multiplicative comparison. We will also discuss how multiplicative comparison is different from additive comparison. Let's compare and contrast two problems. First, Mandy talked to her mom for 5 minutes on the phone. She then called and talked to her dad for 6 minutes. How long did Mandy talk? We can use Cuisenaire rods to represent the information in this problem. We can write an equation to represent the problem. 5 plus 6 equals 11. Now let's look at problem B. Mandy talked to her mom for 5 minutes. She talked to her dad 6 times longer than her mom. How long did she talk to her dad? Problem A is an additive comparison problem, while problem B is a multiplicative comparison problem. To solve problem B, we need to change the phrase 6 times longer into a multiplication problem. Mandy talked to her mom for 5 minutes. She talked to her dad 6 times longer than her mom. How many iterations of 5 do we need to represent the time Mandy talked to her father? We need 6 5 rods. 6 times 5 equals 30, which means 6 times as long as 5 equals 30. Joe has saved $4. Liz has saved 3 times as much as Joe. How much money has Liz saved? Let's practice using the Cuisenaire rods and a number line to write an equation for this problem. We will place one rod from 0 to 4 on the number line to represent the $4 Joe saved. On the second number line, we will lay down 3 rods or 3 iterations of 4 to represent the money that Liz has saved. We can do the same problem on the number line without using the Cuisenaire rods by showing 3 jumps of 4. Using the second number line, we can write an equation that matches the model. Let's write 4 plus 4 plus 4 equals 12, or we can use our knowledge of multiplication to write a multiplication equation, 3 times 4. We write 3 times 4 because there are 3 iterations or groups of 4, and that best represents the information given in the problem. Now we know that Liz has saved $12. Let's look at another multiplicative comparison problem. Admission to the zoo is $3 for kids. Adult admission to the zoo is 6 times as much. How much does an adult need to pay to get into the zoo? We will put a 3 rod on our first number line to represent the $3 kids must pay to get into the zoo. For adults, we will need 6 iterations of 3 or 6 groups of 3 rods to represent the amount that adults need to pay for admission to the zoo. I will do the same problem, replacing the Cuisenaire rods with only the number line. 1 jump of 3 represents the admission price for kids. 6 jumps of 3 represents the admission price for adults. Now, using the second number line, we can write an equation that matches the model. Let's write 3 plus 3 plus 3 plus 3 plus 3 plus 3 equals 18. Or we can use our knowledge of multiplication to write a multiplication equation. 6 times 3 equals 18. We write 6 times 3 because there are 6 iterations or groups of 3, and that best represents the information from the problem. Let's model problem solving a multiplicative comparison problem using only a number line. 2 times 8 equals y. 6 times 7 equals v. When we see 2 times 8 equals y, we know that this is 2 times as many as 8, or 2 iterations of 8. So to put this on a number line, we will make our first jump 0 to 8, and our next jump will be to 16, or 2 times as many as 8 equals 16. When we see 6 times 7 equals v, we know that this is 6 times as many as 7, or 6 iterations of 7. So to put this on a number line, we will make our first jump 0 to 7. Our next jump will be to 14, to 21, to 28, to 35, and finally to 42. Or 6 times as many as 7 equals 42. In this lesson, we use concrete models and pictures to solve equations with multiplicative comparison. We met this objective by learning that in multiplicative comparison problems, we are given a relationship rather than a set of exact numbers to add together.